American manufacturing is dying, but we really have to ask ourselves, why is it dying? In this video, I'm going to tell you everything that you need to know from an engineering perspective in order to become a manufacturer. And at the end of the video, you decide if it is a good idea to tackle this career for the pay that you get. And I think you're going to find it pretty shocking. Now, for the purpose of this video, I am going to combine two careers into one. Some would argue I can combine three of them, but for this video, we're going to stick with two. I'm going to combine an NC programmer and I'm going to combine a machinist into one. The reason why I'm doing that is because I believe that in order to be a good machinist in this modern day and age, you have to become a good NC programmer. So, with that being said, you're probably asking yourself, what is a machinist? What is an NC programmer? A machinist is the person that actually goes and sets up the machine like the one you see behind me. They are in charge of setting up all the tools, setting up all the fixtures, and setting up everything that has to do with this machine. The NC programmer is the person that takes the CAD file, be it a design from someone or something that was designed in-house, and then they generate what's called tool paths in a CAD system. Using the tool paths, they are then able to export that code into a code that the machine understands. If you are familiar with 3D printing, then you probably already know a little bit of it. It's called G code. That is the language that this machine in particular can take, and most modern CNC machines can take. So you can see that both of these careers kind of have to talk to each other in order to be able to produce a good part. All right, let me go ahead and shut down the machine behind me so you don't hear all that bzzz, and then we'll go ahead and continue. All right, so hopefully now you can hear me a little bit better. So, what's involved in being a manufacturer? Let's go ahead and take a look. Now, the first thing that you need to do is you need to pick a CAD package. You need to learn a package that will allow you to create certain tool paths to drive this machine. In other words, your NC programmer application. So, there are a lot of CAD packages out there that can achieve this. There are packages like Siemens NX, CATIA, Mastercam. All of those packages can produce tool paths for you in a very efficient way. You need to pick one of these and you need to learn them. Now, the cost for these, unfortunately, is not cheap. And not only that, sometimes you need to take some master level training in order to even understand how these packages work. Sometimes the trainings can range from simple couple grand to sometimes in the upper tens of thousands. So you can see that the upfront cost for this is quite substantial. But nonetheless, that is the first thing that you will have to do. Think of this like picking what airplane you want to fly. Do you want to fly Boeing or do you want to fly Airbus? Whichever one you're going to pick, you're going to have to stick with. Needless to say, if you work for someone else, you will have to use whatever they impose on you. Now, the second thing that you're going to have to determine is what kind of machine do you want to use. As you can see, I have a Mori MV40 behind me. It's a little old, but it still chooches like no tomorrow. It produces parts at production level, and I honestly love how simple this machine is. So, this one is very hard to put a price tag on. If you go and find a used one like a Fadal, you can probably shell out between $20,000 to $40,000, whereas if you want to buy a new one, it can run you in the hundreds of thousands, if not the millions of dollars. That does not include the infrastructure needed to set up this machine. That is an additional cost that the manufacturer will have to bear. Now, this machine is going to be your best friend. Treat it like your lover. You're going to have to know what it likes, what it doesn't like, what limits it has. You're going to have to be familiar with its size. You're going to have to push it to its limit in order to maximize your profit. So make sure that you understand this machine. Remember, your accuracies sometimes have to be within the limits of a fraction of a width of a hair. You cannot afford to screw this machine up because you're doing something stupid. Now, the third thing that you have to become familiar with, you're going to have to be familiar with tooling. Tooling is what is used to cut material. And sometimes you can go and get tooling from a supplier, or sometimes you need to call out a tooling engineer. Needless to say, this is a pretty big topic and this is not a cheap hobby. These tools are very expensive. A single end mill like this can sometimes run you $500, $1,000, $1,500. And again, that is a cost that you will have to bear. Now, aside from tooling, another thing that you will have to become familiar with is material. The tooling used to cut aluminium is not going to be the same tooling as the one that you're going to use for, say, Delrin. You have to know the differences, and you have to know what tooling you will need in order to cut these materials. So needless to say, you have to become familiar with material itself. You have to become one with the material. With that in mind, you have to also understand the concept of feeds and speeds. How fast can you cut this guy to, say, compare this guy in order to maximize your profit? Think about it. In the machining world, 1 second is a lifetime. Now, why do I say that? Because if you're cutting 1,000 of these parts and you manage to cut your cycle time by, say, 5, 6, even 1 second, you're saving 1,000 seconds or 5,000 seconds, 6,000 seconds, right? If you're cutting 1,000 of these guys, that is a huge cost saving. But you need to have the skill, the craft, in order to know how much you can push these things. And so that's where feeds and speeds come into play. Now, this one is a little controversial because a lot of the feeds and speeds are usually learned through experience. Yes, you can go online and find a book, but the technology, the end mills and the tooling that we have in modern day is very advanced. And some of those tools and some of those books can quickly become outdated. So a lot of these things are learned from experience. And that's where I think we have a little bit of a gap. People who know, who have the experience to cut literally any material known to mankind, at least in America, they are slowly fading away. And we do not have the people around to teach the new workforce how things like this are done. Nonetheless, feeds and speeds, material and tooling, those are all things you will have to become familiar with. Now, some would argue that this can be a college level course, and I actually will agree. Some of this stuff can be, learned in college, but that just shows you the sheer amount of knowledge that you have to understand in order to manufacture anything. And we're not even finished yet. Let's go to the next thing. Now, the other thing that you have to become familiar with is this guy right here. Let me show you. These are jaws for a vise on the CNC machine. You need to become familiar with the concept of fixturing. Fixturing is the art of holding a piece in place so that when you mill it, it doesn't come flying out. And if you ask any machinist around that owns their own shop, they will tell you that the profit is in the fixture. If you know how to make a good fixture, you're gonna know how to make some serious money. This is a skill that is highly sought after. Think about it. If you can design a fixture that can hold 1,000 parts instead of, say, 900 parts, you are making substantial gains in your profit. You're cutting down your cycle time. Now, that kind of brings me to a point that some people really don't want to hear. That is that if you are going to embark on this manufacturing journey, then you also need to be good at CAD. And what that means is you need to be good at designing. You need to be good at designing fixtures, at designing placeholders. You need to be good at all of that. So not only do you have to learn NC programming, but you also have to take on the responsibility sometimes of an engineer and create custom fixtures in order to be able to mill this thing. Now, when you quote these jobs, obviously you want to keep that in mind. You want to have a good idea of what the fixture is going to look like. You're obviously not going to go and design it because you probably don't even have the money for it yet, but you need to be able to visualize it. You have to have that sixth sense of what is the fixture going to look like. Now, another thing that you have to be familiar with is the concept of reading this guy right here. This right here is a print, or what some engineers like to call a drawing. And you need to be good at reading a drawing. This right here is a contract between you and the person who is sending you that drawing. and that contract is going to be used in case anything goes wrong. Now, in the past, all we really used were plus or minus symbols, and that's fine. Most people know how to understand that. But in today's world, we have standards, and there are two particular standards that I am familiar with. In America, we primarily use the ASME Y14.5 standard, whereas in other parts of the world, like Europe, they use the ISO standard. You're gonna have to learn one or maybe both. The unfortunate truth is, if you don't know how to read these, then you are eliminating 75 to 80% of the work that is out there. A lot of the parts that you will get from defense, ITAR, or aerospace contain these funny symbols that tell you the tolerance zones and what type of tolerancing scheme you should follow, and you need to be good at it. So again, that's just another thing that you will have to add to your manufacturing tool belt. Are you getting overwhelmed yet? Do you see everything that you need to know in order to become a manufacturer? We're not even done yet. There's another thing that I think you will have to learn. You're gonna have to be good at inspecting. Now, not everything needs to be inspected, but sometimes the customer might request a certificate that says, hey, I want to make sure that you inspected this. Again, this is mostly for aerospace and defense parts. You need to be good at it. You're going to have to purchase some very expensive gauge blocks, or if you have the big money, you're going to have to whip out money for a CMM machine. Again, this is a career that I decided not to involve in the beginning, but at some point, you will have to inspect some parts, and you're going to have to know how to do it, or you're going to have to know someone who can do it. And guess what? They don't do it for cheap. They are really expensive. So I've given you all of the responsibilities that a manufacturer is responsible for. Now let's ask ourselves this. How much does it pay? Surely, I mean, all the stuff that you have to know, the tooling, the material, you need to have the infrastructure, you need to be a machinist, an NC programmer, you need to be all of these things. Surely the wage for this is great, right? Well, it depends. First, let's look at it at an individual standpoint. Now, let's talk about the machinist first. Remember, the machinist is the person who is going to actually set up this machine. They are not in charge of making the tool paths. That's the NC programmer. They are just in charge of setting all the tool offsets, setting up all the fixtures in here, setting up all the tools in the machine, all that stuff, maintaining this thing, right? How much do those guys get paid? Now remember, you are dealing with parts that are close to perfection. You're dealing with things that have tolerances the width of a bloody hair. How much do they get paid? $150,000? $100,000? The median salary in America is 50 grand. 50 grand a year to manage a machine like this that handles tolerances that are tighter than the width of a hair. For you engineering nerds, right? 1/10 of a thou, 5 thou, 2 thou, 1 thou, 50,000 a year. Ask yourself, is that really worth it? Putting your life in danger. Remember, this thing can kill you. Putting your life in danger, setting up machines like this for 50,000 a year? I don't know. I'll let you come up with that decision. What about an NC programmer? Those guys, are you ready for this? Remember, those are the folks that are in charge of actually making the tool paths on the computer. They create all of the tool paths. They specify all the feeds and speeds, all that. How much do those folks get paid? On average, $79,000 a year. $79,000 a year. Think about that. Is that really worth it? You sitting there coming up with the best of the best in order to manufacture things quickly to save the company money? $79,000 a year? I'll let you decide. Now, I want you to really understand that both of these jobs require expert level technique. I'm really simplifying a lot of this stuff for you, but these jobs require expert level technique, fine attention to detail. Anything that gets screwed up in either the NC programming side or the machinist side can result in catastrophic failure. $50,000 a year for a machinist, $79,000 a year for an NC programmer. Is that worth it to you? All right, let's say that we combine these, right? I mean, let's say we combine both the NC programmer and the machinist, which is honestly what happens in a lot of companies. A lot of companies now say, hey, we shouldn't hire, 2 people to drive this thing. Let's just hire one person. They will be the NC programmer and they will be the machinist. If you combine both of those salaries, That's $129,000. Again, is that really worth it to you? Now remember, if you decide to take on this, you're now responsible for two things. You're responsible for maintaining this machine, setting up this machine, making the fixtures work, setting up the vise, all the tools, and you're responsible for programming this bloody thing. Is that really worth it to you? Ask yourself that question. I'll let you decide. But if you were to ask me, it probably isn't worth it. I can make more money being an ME, a civil engineer, and technical drawings, coming up with designs, instead of having to set this thing up and, putting my life in danger, coming home with smelling like coolant and all that stuff, right? And that's why I think this industry is dying, because nobody wants to do it for that pay. And this is a field that just doesn't have the people around anymore in order to train our upcoming workforce. It's not something like an electrician or an influencer, right? Everyone wants to be an influencer, but nobody wants to be a machinist. Nobody wants to be an NC programmer, right? Very few people want to be that. For the pay and for the status that it has in America, that's why it's dying. And unfortunately, unless we do some heavy investing in this workforce, unless we explore some technological advancements, it's only going to get worse. Thank you guys so much for watching. I would love to hear your feedback and what you think we can do in order to bring this industry back. Thank you guys so much for watching, and take it easy.